All right, so we started off chapter 11, which is volume now. But first of all, 11.1, cross sections and solids of revolutions when you rotate 360 degrees. Okay, so two new vocabulary to what is a cross section. It's where you, in other words, a bit like a loaf of bread. When you cut through it, you make sections. Okay, and then what would be the solid after you rotate it 360 degrees. All right. Now, most of the time, when you do a cross section of a solid, most of the time you finish up, especially if it's a horizontal or vertical cut. Then, like in the sphere, if I look at the sphere, if I put a cut all the way through the cylinder, the sphere, and then look at what you've got, you'll actually get a circle. Okay, and the same with the cone. This one here, you will again get a circle, because obviously the cone is in circle sections, because that's horizontal as well. But this one here, where you've got a slight taper to it, if you cut through that, you will actually get an oval. Okay, so be careful with some of the shapes. And then obviously the cylinder, if you cut the cylinder through again, as you can see, you get a circle. So normally, if you cut horizontally or vertically through any 3D shape, you will always get a 2D figure. So let's have a look at question number 1. Okay, you've got to determine what the cross section is formed and describe the plane of the solid. Well, question number 1 says a plane perpendicular to the base. Well, don't forget, perpendicular to the base will go like that. Okay, don't forget it's at right angles, and when you open it out, what you're actually going to get, as you can see, is a rectangle. So even though you've got a cylinder, you finish up with a rectangle. So just be careful of what you're going to find when you're finished. So let's carry on and move over to question number 3. This time a plane of an angle relative to the base through opposite faces. Okay, so basically you're going to get a diagonal that looks like that. Well, you start off with a square, but if you rotate it round, you're actually going to get a rectangle again, because this side is the hypotenuse and it has to be longer than the other 6 sides. So again, you've got a rectangle from what is basically a cube. So what happens when you take a shape and you rotate it 360 degrees around an axis? You actually get the solid of revolution. And as you can see, you start off with what basically is a triangle, but if you rotate a triangle around its axis 360 degrees, you're actually going to get a cone. And then obviously you finish up with the base is going to be a circle again. So again, make sure you try and work out what will it look like when you rotate it 360 degrees about an axis. So let's have a look at example 2 in play. All right, now as you can see, question 4 and question 6 is actually on the axes, but question 5 isn't. So that's going to be a different one, a different type of shape, and well, you'll see when we get to it. All right, but number 4 is a rectangle. Well, if you rotate a rectangle around about, so you start off at this point here and you're rotating it 360 degrees, and it's going to be in this shape. And as you can see, I'm finishing up and I'm actually making a cylinder. All right, so again, we start with a rectangle, we finish with a cylinder. So now let's have a look at this question number 5. Okay, now question number 5, you've got a circle, but it's not on the line. Well, if you rotate a circle around a line, what you're actually going to get, believe it or not, is our wonderful donuts. There is a proper name for it. It's called a torus, but you'll know it better as a donut. Not quite as good as a Boston cream donut, but just as good.